Okay.
Hello, everyone. My name is Francesca Tabor. I am delighted to have with us Sanjay. Thank you for joining us from Austin, Sanjay. How are you doing?
Great. Thank you so much. How about you?
Yeah, very well. So Sanjay is going to do a presentation on the impact of sentiment analyses in improving fake news detection using AI, which is going to be very important, especially as we're coming into an election year, and we're going to see a lot of fake news coming onto our social networks, and we'll have to be discerning. So it'll be great for AI to help remove some of the disinformation out there and the noise. Sanjay has over 18 years of experience in software development and support with expertise in Microsoft Visual Studio, .NET, and various other development methodologies. So I'll pass it over to you. Thank you so much for joining us here today.
Thank you so much, Frankie. My name is Sanjai Kanth, and the topic that I'm going to take is the impact of sentimental analysis in improving fake news detection using artificial intelligence/AI. I'm a staff site reliability engineer at Visa Inc. and a third-year PhD student from University of North Dakota. So the next 30 minutes of the presentation will go as first we'll talk about some introduction, and then we'll go as a background, and we'll discuss about the proposed research and the different algorithm that we used. And we will talk about the system structures and what about the experiment results. And finally, we will summarize the talk. And if you have any questions, we can take some QA as well, the time permits. So what is an information? 1 second, let me see if I can hide this. Anyway, I'm not sure. Okay. So what is an information? Based on the Oxford Dictionary, information is a knowledge communicated or received concerning a particular fact or circumstances. The word communicated or received is crucial here because what we are communicating and what we are receiving is very important here. And we need to make sure that we are receiving the right information. This is the fundamental of this talk, where we are communicating different types of informations. A message is categorized into one of the following 5 classes. One is a true information. I'll be talking about in detail in the coming slides, but let me go with each and every different types of informations available. One is true information and fake information, misinformation, disinformation, and a neutral information. And I'm going to talk about what is each. And don't worry, I'll be giving an example about each of the sections as well. A true information is an information, and there is no doubt about the information that is being passed. A fake information is an incorrect, and we know that it is incorrect. A misinformative information is a false or out of context information that is intentionally or unintentionally. The word is intentionally or unintentionally is crucial here, presented as a fact to deceive. A disinformation, which is a type of misinformation that is intentionally delivered. The difference between misinformative and disinformative is, in terms of misinformative, it can be received intentionally or unintentionally. But in case of disinformative, the message is passed intentionally. And we know that the information is wrong, and it's a misleading information as well to deceive or mislead readers. And the last category of the message is called a neutral, and that we cannot be decided by the proposed methods or available informations. So what is, now you might be asking about what is the difference between misinformative and disinformative, and if we can provide an example about it. The misinformation is that you think it is true, but it is not. And disinformation is that you know it's not true, but you say it anyway. So that's the difference between misinformation and disinformation. In this age of COVID-19, the disinformation is more dangerous. Even disinformation is more dangerous than misinformation. At least misinformation, the person who convey the results or convey the message, at least he doesn't know whether it is a true or false, but he still relay the information to others. But in terms of disinformation, The person who knows that it is wrong, but at the same time, he passes this information to others. So I'm going to talk about each and example of each of these different types of messages here. True information example is that COVID-19 is caused by SARS-CoV-2 virus, which is true, that's why it is called true information. What is a fake information? Drinking bleach can cure COVID-19. We all know that it doesn't cure COVID-19 by drinking bleach. So, which is a fake information. What is a misinformation example? An example is that wearing a mask can reduce your oxygen level significantly. We may say that, okay, the intake of the oxygen can be reduced when it is obstructed by a mask, but in reality, it is not. We get the same level of oxygen, as we are not wearing a mask. So we know that it is. We think that this is a true information, but it's actually not true information, and we are passing this information to others without realizing that it's a fake information. And an example of disinformation is that COVID-19 vaccine contain microchips for government tracking. Say, like, people were thinking, like, when you're injecting a COVID vaccine provided by the government, um, people, there was a rumor spread across, or a disinformation spread across, saying that the government has put, chips inside the the vaccine, and then they can control you, or they can even track you. And there are some rumors that you may be even attracted to the magnets also. So this is a classical example of disinformation. What is a neutral information example? It's a World Health Organization recommends frequent hand washing and social distancing to prevent the spread of COVID-19. This neutral information may be, maybe a neutral information uh, during the start of the COVID-19 pandemic. Now we know that it prevents, but during the initial COVID-19 pandemic time, it was not at all. We don't know whether it was true or not. So there was no specific methods to verify uh, verify whether the message was passed is right or not. So that's why we categorize this neutral information. So the different types of information as a true, fake, misinformation, disinformation, and a neutral information. So this is now let's talk about a little bit background about this discussion. Um, we are discussing based on the COVID-19 pandemic era. So this is the status available for COVID-19 pandemic. We can see this stats on a daily basis from worldometer.info. If you are interested, please go through this website where it will clearly explain about worldwide and countrywide status as well. So I took the status today morning, and the last updated time was April 13. Maybe because the COVID-19 is not that as a major issue. So the last updated was April 13, and worldwide 704 million people were affected, and 7 million people was dead because of this COVID-19. US was worst affected by this virus, and 111 million people were affected, and 1.2 deaths has happened. And this is the graphs of 7-day graph of COVID-19 that you can see. And if you are interested, please go through this website where you can get a clear idea about how many worldwide cases, how many deaths, how many recovered, and etc., etc. And you can see even the countrywide status as well. So what is health misinformation? Our topic is mainly based on fake news detection, but the research is based on the health misinformation actually. So according to a World Health Organization and Department of Health and Human Services, on some social media platforms, falsehoods are 70% more likely to get shared than accurate news. Meaning, like, if you are using Facebook or Twitter or LinkedIn, people may be, spreading some kind of information, and it may be false news. There are 70% chances that it is shared compared to the accurate news. Even a brief exposure to COVID-19 vaccine misinformation made people less likely to want to COVID-19 vaccine because, there was news about the efficacy of COVID-19 different vaccines, and people doesn't want to take the COVID-19 vaccine because they were not sure about it, and there was a disinformation spread. People think like, there can be a long-term effect of due to this COVID-19 vaccine as well. So people were reluctant to take COVID-19 vaccine. They were, delaying it for a period of time, and that was the reason why this research topic is about to reduce the fake news and provide a system that gives machine learning models or a proposed system to give a maximum, a better way to assess fake news in this COVID-19 era. The research can be extended for any other topic as well. Misinformation has also led to the harassment and violence against public health workers, health professionals, and airline staff and other frontline workers. So, it is kind of critical to come up with the solutions on how we can, contain the fake news spread in the, online social medias and online mobile health messages as well. And due to this, a lot of misinformation available over the internet, World Health Organization has led to the removal of 850,000 YouTube videos related to harmful or misleading COVID-19 misinformation from February 2020 to January 2021. Look at this, the duration. It's just 11 months. And, WHO has to remove 850,000 YouTube videos. This research proposes a system to identify fake news by combining the results from several ensemble methods, including backing, boosting, stacking, and voting means. And we also use a recurrent rule methods. The core concept is not about to use the different ensemble models or RNN or recurrent neural network to find out the fake news. We do have a number of um, um, research already available to find out the fake news by using all these ensemble methods, RNN, CNN, and all those machine learning models. But the research, our research aims to use the sentimental and emotional analysis are employed to determine whether the accuracy of fake news detection can be improved. So the fundamental idea is, we do have the existing research available in the internet or in the research field to use the different types of machine learning models to find the fake news detection to have a better accuracy. But the talk is about how we can use the sentimental and emotional classifiers to use to improve the fake news detection accuracy. So I'm not going to talk about what would be the accuracy of the machine learning models. It can be very different, using hypertuning parameters and all those stuff. But I'm only talking about, is there any way we can improve the existing? Say, like if you have a machine learning models, and is there any additional ways that you can use to improve the accuracy of these machine learning models for a fake news detection? So as every data machine learning models that we do a data cleanup, and we remove the stopboard removal for each of the messages that we received, and we do the stemming, and we add a sentimental analysis, and we do the emotional analysis, and we do the tokenization, and we use the padding as well as a data pre-processing steps. So stop word removal is nothing but, removing the frequently occurring word. So my name is Sanjay Kanth. So I can remove my, which is a frequently occurring word, and we can keep it there. But the word is a frequently occurring word, and we can remove that. That is considered as a stop word, and we don't need to include that in our machine learning models, because it doesn't make any sense. It doesn't change the underlying meaning of the text messages that is available. So we can remove every unnecessary data and include only the core data or core words that we need to use. Stemming is like, say, trimming of the words and to its root, meaning saying, suppose the word called say, says, said, saying something like that can be trimmed to say a word called say. So I'm saying that this is the right choice. This is a sentence, right? So in that word, there's a say. I said this is the right word. In that sentence, there is a word called say. So this saying and say, these two words can be combined and can be treated as a single entry. So that is that process is called stemming. Sentiment analysis and emotional analysis, I'll be talking as we progress. Tokenization is a process in which we convert a word into tokens. Padding is nothing but, if we have a data, if we don't have sufficient lengths required to process the data into the input required in the machine learning models, we pad that with corresponding data. So what is a sentimental classifier? A sentimental classifier is the way in which we classify the data or the input as negative, positive, and neutral. And this way we will say like, okay, this is a good data. I mean, this is a positive data, negative data, or neutral data. One of the example for a positive sentence is like, it's a very good day. That's a positive day, positive sentiment. Negative sentiments is like, okay, it's a rainy day and I don't like it. That is a negative sentence. A neutral sentence is like, today is Wednesday or today is Thursday or Fridays. That is a neutral sentence. There is no sentiment associated with those sentences. So these three are the different classifications of sentimental classifications that, when we have a data or when we have a message, when we have an input, we classify it as a negative, positive, and neutral. And what is an emotional classifier? Emotional classifier is nothing but we take the emotions in from that input message and classify as the different types of emotional classifiers. The different types of classifiers are love, joy, sadness, surprise, fear, and anger. This way we can classify emotions, and we can use this emotion classifiers, and we can append these emotional classifiers as an input to the input text message, so that we will be seeing whether it will increase or decrease, or it doesn't make any changes in the accuracy of the machine learning method or fake news detection models. So this is the data that I have used for my study, and around 50% was negative, and 44% was neutral, and positive was only 5%, 5.7%. When it comes with emotional classifier, anger was 56%, and love was only 0.6, joy was 23, and rest are as you see in the screen. So the underlying research is to use these classifiers and add as an input in the text message and see whether we can improve the accuracy. Say like COVID-19 is originated from from a Chinese labs. If we say like that, the 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 sentimental classifier will be negative. So we will be adding that sentimental classifier as an input. Say so the final text message will be the COVID-19 virus was originated from a Chinese labs negative. We will add this one. At the same time, we do add the emotional classifier as well. So COVID-19 vaccine originated from a lab in China, uh, negative, and we add a fear as well as a text message in that. We will be using ensemble methods. We'll be using a concept of ensemble learning in machine learning models in the proposed system. What are the different ensemble models? One is bagging, one is boosting, one is stacking, and one is random forest or the voting. So what is the bagging? Bagging is like, we have a 1,000 records, and we will be splitting those records into a different chunks. Say like, from 1,000 records, we will be splitting it as 3 different types of data set, and one will have 500, another will have 600 or 500 different um, sets of 500, and the third one also will be having different sets of 500, and we will be having a multiple machine learning models, and we train this one in these data, and And we finally do a voting in that one. So first data will be coming from here, and it will say, hey, this is a true news, and second one will say true news, and but the third one will say a false news. But the output will be based on different algorithm, whether it can be a maximum number of people who voted. It will be the output of that machine learning model. So that is called bagging. So an example of bagging is that, so we do have a data set here, and we split this data set as a different types of data set. Like I mentioned, we had earlier 1,000 records, and we split it as 500 records, and we send it to a machine learning algorithm, and we do combine all these methods, and we finally we give the correct answer. We propose an answer. So in this way, we can use multiple machine learning models, and we can specify which one can be accurate. We can improve the accuracy of these models rather than as an independent standalone models. What is boosting? Boosting is nothing but we do have a data set. We try to pass into one machine learning models, and we do then the output is passed to a second another data set is passed to the same machine learning model. We will be knowing this one over a period of time, and final one, this we will be getting a complete well trained machine learning model that will give us the accuracy. So here is an example. Here we have an initial data set, we passed to a machine learning model, then we new set of data is passed, priority cases for which the previous algorithm was mistaken. So it will be trained over sequentially, and finally repeat until it feels we are good. That is called boosting. Ensembling is like, we do have a different machine algorithms here, and we do parallelly, and finally we do a first level of predictions, and the prediction is passed to a meta classifier, and we get a final predictions. This is an example where we have some data, we pass it to a KNN, and we can pass it to CNN, I mean decision tree and SVM, then we do a final decision algorithm, and we get the answers. This is a proposed system structure where we do have an input data set, we do all the pre-processing steps, and there are two ways actually. So we will be calculating different ensemble methods like bagging, boosting, stacking, voting, and we will be using RNN also standalone, and to see whether it has any impact or not. So we pass the data to a decision rules engine. And the second flow is that we do have the same structure here. We use it here as well. And at the same time, we do sentimental analysis, emotional analysis, irony analysis, and hate speech. And we append those data to the different ensemble methods, and send it to the decision rules engine. DRE decides which one is the result based on the accuracy or the comfort level or confidence level. The experiment setup is that we do have a training data, and we send it to we send it to the proposed system. We store the data in the database, and when we receive a test message, we pass it to the system, and we get the result. This is a mocked up data of how the UI looks like. We do receive a different messages, like message 1 to 6, and we click on it, and we read the message. When when the new screen appears, and we can click on the check button, and it will go to the message will pass to the machine learning models, and we receive the information as its information or true, like that. So this is the accuracy that we received. You don't need to worry about what is whether the accuracy level, but were getting about 99%. This is without the sentimental and emotional classifiers. So backing, boosting, stacking, voting, and standalone, they were getting around about 99%. Boosting was around 90% only. This is the accuracy of when we are adding a sentimental, emotional, irony, and hate speech classifier to the input. See, if you look here, if I go back here, 99.26 increased to 99.86, and 90.06 increased 94, 99.19 increased to 99.86, RNN 98.99 to 99.88. This is the crux of this discussion. Here you can see we are doing the comparison of this different machine learning model with and without sentimental analysis. I use the term sentimental analysis, but we are using a different, we are not just using sentimental analysis, we are using emotional irony and hate speech as well as passing into the input. If you look here, the blue is without sentimental analysis and the orange one is with sentimental analysis, and this is the accuracy here. And this is the different machine learning model, whether it is RNN, voting, bagging, boosting, and stacking. Here you can see that when we are adding the sentimental classifier, the accuracy has increased. Here it is now from 98 plus to near 100. Here also it is in the voting increased from 98 to nearly 100. Bagging also, as you can see, it is increased from here to here. Boosting had a bigger jump from 90 to 94 plus. Stacking also increased the accuracy level. So the idea is to make use of the sentimental emotional ironic classifier and and add it so that we get a better accuracy of this fake news detection models available. Right now, whatever it's available over the internet, they are using 90% or 95% of them are only using different types of machine learning models. But we can the the purpose of this research was to find out uh, whether we can improve the accuracy by using this different machine learning models. Here's this confusion matrix. 4,307 was correctly predicted with the backing. Um, only 4 was incorrectly predicted. And here fake was incorrectly predicted as 11, but correctly predicted as 4,600. So if you look at only the diagonal, here is the correctly predicted, and this diagonal direction is the downward direction is the correctly predicted, and upward direction is the incorrectly predicted. So here, if you look here, it is more and it is less. It is more here, it is less here. It is more here, correctly predicted, whether it's true or false. Incorrectly predicted, stand and fall. Here also it's the same. Accuracy is 99.83 for bagging, 94. We increase the boosting accuracy 94. Tracking means 99.86, and voting is 99.84, and RNN 99.88. The standalone RNN received higher accuracy when we are adding a sentimental classifier. So now, so the answers to the research questions was we can use the different ensemble method to find out the fake news to implement a fake news detections application. So we can use all this bagging, boosting, stacking, and voting to detect misinformation or fake news detection. And we can also use RNN models to find out the accuracy, and it was giving a much higher accuracy when we are using a standalone RNN model um, when performing without sentimental analysis. And when we are integrating sentimental and emotional classifiers, it contributes to improve the accuracy of the ensemble methods. So we were getting an accuracy of about 99.87%. That is near 100, which means that we could use this machine learning models to get a better, higher accuracy. Moving forward, the most accurate models can be selected to improve an online fake news detections, which could help combat the spread of misinformation. And suggested research topic is that we using other RNN neural networks to handle a sequential data will be considered next, and then can be considered because the problem has no definite answers. Statistical means will be considered too. We can also consider that one. This problem, mobile health misinformation identification, can be classed as one of the NLP, natural language processing problems. Besides that, there has been a rising interest in proactive intervention strategies to counter the spread of misinformation. If you do have any questions, I'm more than happy to take up.
Wonderful. Yes, I have a question. I was wondering what sort of seminal research has come out recently that is pushing this field forward, if there are any research developments.
This is the first time a research has been done to find out the effect of the sentimental classifications to improve the fake news accuracy. And the to answer your question, why did I come across, or if there is any research available, this is one of the main topic in my PhD study. That's why I did the study. And moreover, during the COVID-19, there was rising interest to find out. There was a lot of fake news available over the internet. So there was a rising interest of, um, implementing a better fake news detection system, or better fake news applications, so that people will get more idea about how to get an informative decisions, rather than relying on the Facebook data, or Facebook message, or LinkedIn message, or Twitter messages, etc.
Wonderful. And then from your research, were you able to benchmark various different platforms against each other in terms of fake news, whether it was Facebook or Twitter, X or Meta or LinkedIn or YouTube? Is there any are there any think tanks out there who do research on this on an ongoing basis?
Yes. Yes, very good questions actually. There is a public data set available for Twitter, which is called Twitter 15 and Twitter 16, etc. So in if you're asking me about which public platform has contribute more on the misinformation spreading, Twitter is one of the top, will be on the top first level to spread the misinformation. And there is one more thing. There are two characteristics of a fake news. One is, a fake news will travel a long distance compared to a true news. Say like, okay, today a true incident happened. Say like, okay, there was an accident in the Palmer Lane in Austin. That is a true information. It will be there probably today, tomorrow, or a week's time. But a fake news will be there for a longer period of time. Meaning, government is injecting chips in the COVID-19 vaccine. That misinformation was there from 2019 or probably 2020, and it is still being circulated even now also. So a true information travel a short period of time, but a fake information travel a longer period of time. That is one characteristics of fake news. A second characteristics is, we are talking about the spreading of the misinformation, right? So a super spreader is a term that we use. It is nothing but the person who spread the misinformation more than anyone else. So usually a fake news is originated from a less follower Twitter user. Say like the user might be having 5 or 10 followers, and he will be originating a fake news. And the important thing is, it is retweeted or shared by a follower or a person who has more number of followers. Say like the person who create the fake news might have only 5 or 10 followers, but the person with say like 100,000 followers, if he retweet the fake news, that's spread very rapidly. So when I analyze the data in the available Twitter data set, what I've seen is that it always originated from a lesser number of follower user, but it is reused or retweeted by a large number of follower user.
Okay, so you can analyze the network effects to see if
Exactly.
this was a bot or artificially promoted across the network. That makes sense.
Exactly.
And then when we look at the training of large language models, especially some of these general purpose models, so for example, OpenAI's ChatGPT, a lot of those models were trained on social media content. Maybe it was licensed from Twitter X, or maybe it was just scraped from the internet and harvested. So what happens when misinformation starts to train these large language models, which it's very difficult to then extract that information once it's gone to training the model.
So, we do this ChatGPT and other LLM, they definitely have their own data set, and they are self-trained, meaning like, even if there is a fake news is there, they use the credibility of the sources as well. Say like, some fact checking sites are there, and some credible news channels are there. these LLM, get the data from those news channels, but they some of the studies that uses this fake news detection, they rank the credibility of the sites too. Say like, okay, CNN, Fox News, and all this channel. If the news comes there, there's a good chance that they are credible compared to some XYZ news channel where the news comes. So we can utilize these LLM internally use these source website to get trained the data. At the same time, they also use the ranking. So if two news comes at the same time, one say like, okay, today is Monday. If it comes in one XYZ, and another news that today is Wednesday, it comes in Fox News or CNN. So when we are looking at the data, it's one data is coming from one source and one data is coming from another source. So it gives more priority to the data that coming from a reliable data source. That's how this LLM works.
Wonderful. So I do have one last question. So how could you or will you go about commercializing this research and actually creating an algorithm that can be utilized by some of these platforms, for example?
uh, Commercialization is they already have the different types of machine learning, I mean, models for to detect the fake news itself. I am not thought about the commercialization for my studies, but I'm pretty sure that it can definitely improve the accuracy. Fake news.
Fantastic. Well, thank you so much for your time today. Do you have any last thoughts for the audience who are listening in?
Yes, my first request is that there are a lot of data available over the internet, and please don't rely only on the data. And especially when it comes with um, um, health information, please consult physicians, and don't rely on just on the these online news and all those stuff. There are a ton of misinformation available, and please don't when it comes with the healthcare and all those stuff, please use this please consult a physicians or someone, and don't do the remedy by yourself.
Okay, brilliant, brilliant advice. Thank you so much. Great. Well, have a lovely rest of day, and I'm looking forward to having you back for the next part of your presentation and to see where your research goes next.
Thank you so much. I really appreciate it. Thank you for
Okay.
giving me an opportunity to present as well. Thank you, everyone.